as a single cell. It multiplies to 2, 2 becomes 4, 4 becomes 8, and some of those cells have to divide thousands of times. In fact, even as I stand here before you, all throughout my body, cells are furiously replenishing. Every time a cell divides, all of its DNA has to be copied, all of the coding DNA inside of those chromosomes, because that carries the vital operating instructions that keep our cells in good working order. But there is a glitch in the way DNA is copied. Every time the cell divides and the DNA is copied, some of that DNA from the ends gets worn down and shortened, some of that telomere DNA. Generally speaking, the longer your telomeres, the better off you are. It's the overshortening of telomeres that leads us to feel and see signs of aging. My skin cells start to die, and I start to see fine lines, wrinkles. Hair pigment cells die. You start to see gray. Immune system cells die. You increase your risks of getting sick. In fact, the cumulative research from the last 20 years has made clear that telomere attrition is contributing to our risks of getting cardiovascular diseases, Alzheimer's, some cancers, diabetes, the very conditions many of us die of. So it's the year 2000. I've been minutely scrutinizing little teeny tiny telomeres when into my lab walks a psychologist named Elissa Epel. Now, Elissa's expertise is in the effects of severe chronic psychological stress on our minds and our body's health. And there she was standing in my lab, and she had a life and death question for me. What happens to telomeres in people who are chronically stressed? She asked me. You see, she'd been studying caregivers, and specifically mothers of children with a chronic condition, be it gut disorder, be it autism, you name it, a group obviously under enormous and prolonged psychological stress. I have to say, her question changed me profoundly. See, all this time I'd been thinking of telomeres as those minuscule molecular structures that they are and the genes that control telomeres. And when Elissa asked me about studying caregivers, I suddenly saw telomeres in a whole new light. I saw beyond the genes and the chromosomes into the lives of the real people we were studying. And I'm a mom myself. At that moment, I was struck by the image of these women dealing with their child with a condition very difficult to deal with, often without help. And such women simply often look worn down. So was it possible their telomeres were worn down as well? So our collective curiosity went into overdrive. Elissa selected for our first study a group of such caregiving mothers, and we wanted to ask, what's the length of their telomeres compared with the number of years that they have been caregiving for their child with a chronic condition? So 4 years go by, and the day comes when all the results are in. And Elissa looked down at our first scatter plot and literally gasped, because there was a pattern to the data. It was the exact gradient that we most feared might exist. It was right there on the page. The longer, the more years, that is, a mother had been in this caregiving situation, no matter her age, the shorter were her telomeres. The more she perceived her situation as being more stressful, the lower was her telomerase and the shorter were her telomeres. So we had discovered something unheard of. The more chronic stress you're under, the shorter your telomeres, meaning the more likely you were to fall victim to an early disease span and perhaps untimely death. Our findings meant that people's life events and the way we respond to these events can change how you maintain your telomeres. Now, luckily, hidden in that data, there was hope. We noticed that some mothers, despite having been caring for their children for many years, had been able to maintain their telomeres. So studying these women closely revealed that they were resilient to stress. Somehow they were able to experience their circumstances not as a threat day in and day out, but as a challenge. And this has led to a very important insight for all of us. We have control over the way we age, all the way down into our cells. Okay, now our initial curiosity became infectious. Thousands of scientists from different fields added their expertise to telomere research, and the findings have poured in. It's up to over 10,000 scientific papers and counting. So several studies rapidly confirmed our initial finding that, yes, chronic stress is bad for telomeres. And now many are revealing that we have more control over this particular aging process than any of us could ever have imagined. A few examples. A study from the University of California, Los Angeles, of people who are caring for a relative with dementia long-term and looked at their caregivers' telomere maintenance capacity and found that it was improved by them practicing a form of meditation for as little as 12 minutes a day for 2 months. Attitude matters. If you're habitually a negative thinker, you typically see a stressful situation with a threat-stress response, meaning if your boss wants to see you, you automatically think, I'm about to be fired, and your blood vessels constrict, and your level of the stress hormone, cortisol, creeps up, and then it stays up. And over time, that persistently high level of the cortisol actually damps down your telomerase, not good for your telomeres. On the other hand, if you typically see something stressful as a challenge to be tackled, then blood flows to your heart and to your brain, and you experience a brief but energizing spike of cortisol. And thanks to that habitual bring-it-on attitude, your telomeres do just fine. You really do have power to change what is happening to your own telomeres. But our curiosity just got more and more intense because we started to wonder, what about factors outside our own skin? Could they impact our telomere maintenance as well? You know, we humans are intensely social beings. Is it even possible that our telomeres were social as well? And the results have been startling. As early as childhood, emotional neglect, exposure to violence, bullying, and racism all impact telomeres, and the effects are long-term. Can you imagine the impact on children of living years in a war zone? People who can't trust their neighbors and who don't feel safe in their neighborhoods consistently have shorter telomeres. So your home address matters for telomeres as well. On the flip side, tight-knit communities, being in a marriage long-term, and lifelong friendships even, all improve telomere maintenance. So what is all this telling us? It's telling us that I have the power to impact my own telomeres, and I also have the power to impact yours. Telomere science has told us just how interconnected we all are.